In this video, I want to talk about reflecting figures on a coordinate plane. So first, let's take this triangle ABC and reflect across the y-axis. So when we're reflecting across either of the axis lines, it's very easy to make sure that we do that in a perpendicular motion because we're just following the grid lines, and the grid lines are perpendicular to each other. So when I'm looking to reflect A across the y-axis, all I have to do is notice that A is 7 steps to the left of y, so A prime will end up 7 steps to the right of y. So this is the location of A prime. B is 1 step to the left of y, so B prime will end up 1 step to the right of y. And C is 3 steps to the left of y, so C prime will end up 3 steps to the right of y. And we just connect the dots. And now we have reflected triangle ABC across the y-axis. Now let's take a look at how the ordered pairs for each point change so that we can find the pattern. So A was at -7, 8, and whereas A prime, it's at +7, 8. And B was at -1, 6, and now B prime is at 1, 6. And C was at -3, 2, and C prime is at 3, 2. So if we look at how each point changes, we notice that the x values are opposite. We go from -7 to +7, from -1 to +1, and from -3 to +3, but the y values stay exactly the same. So the rule is this, the pattern is this. When reflecting across the y-axis, xy becomes the opposite of x, y. So the y value stays the same, and we just take the opposite of the x value. And this is the pattern that will always be true whenever we reflect an image across the y-axis. Now let's take this same image, triangle ABC, and reflect it across the x-axis. Again, in order to stay perpendicular, all we got to do is follow the grid lines. So I notice that point A is 8 units above the x-axis, so A prime is going to be 8 units below the x-axis. And B is 6 units above the x-axis, so B prime is going to be 6 units below the x-axis. And C is 2 units above the x-axis, so C prime will be 2 units below. And we just connect the dots. And here is our reflection of triangle ABC across the x-axis. Now let's take a look at how the ordered pairs change for each point when we reflect it across the x-axis. So again, A was at -7, 8, and A prime ends up at -7, -8. And B was at -1, 6, and B prime ends up at -1, 6. And C was at -3, 2, and C prime ends up at -3, -2. So we can see here that now this time, when we reflect it across the x-axis, the x values stayed the same, and the y values were opposite. We went from +8 to -8, from +6 to -6, and from +2 to -2. So the pattern, the rule when reflecting across the x-axis is that x, y become x, the opposite of y, or -y. And that is always what happens whenever we reflect a figure across the x-axis. All right, so now let's take a look at reflecting a figure across the line y equals x. So this blue line here is the line y equals x. If we think slope-intercept, y equals mx plus b, okay? So we see that the slope is the coefficient of x, so our slope is 1. And our y-intercept, in this case, would be 0. So this diagonal line that goes through origin and has a slope of 1, this is the line y equals x. And this line cuts through the coordinate plane at a 45-degree angle. So then the question becomes, how do I reflect across this line and make sure that I am moving in a perpendicular fashion? So when you have this line, the way you make sure that you have 90-degree angles is by moving diagonally across the grid lines. So if we take a look at point A here, I'm going to go ahead and move in green diagonally across these lines. So I'm going 1, 2, 3, 4, 5, 6 diagonals to get to the line. So I'm going to go 6 in the other direction. So 1, 2, 3, 4, 5, 6. And so this is the location of point A prime. Let's do the same for B. B is a little easier because it's closer. B is just 1 step diagonally. So I'm going to move 1 step diagonally in the other direction. And there's the location of B prime. And if I look at C, C is going to move 1, 2 and a half. So I'm going to go half, 1, 2. And that gives me my 2.5 in the other direction. And this is going to be the location of C prime. And all I got to do is connect the dots. I had it marked B prime, which is right here. And so there we go. We have successfully reflected triangle ABC across the line y equals x. Now let's take a look at how the ordered pairs for each point changed so we can see the pattern. So A was at -7, 5, and A prime ends up at 5, -7. And B is at 4, 6, and B prime ends up at 6, 4. And C was at -5, 0, and C prime ends up at 0, -5. So if we look at the way that the ordered pairs changed, what we see here is that the x and the y values are switching. We went from -7, 5 to 5, -7, from 4, 6 to 6, 4, from -5, 0 to 0, -5. So the pattern, the rule when we reflect across the line y equals x is x, y becomes y, x. And so this is going to happen every time you reflect an image across y equals x, the x and the y values will switch. So now let's reflect an image across y equals -x, and we can see that this is the same type of line, cuts through the coordinate plane at a 45-degree angle, but it is going in the opposite direction. That's because, again, if we think y equals mx plus b, now our slope is -1. And our y-intercept is still 0. So when we go to reflect, we're going to do the same thing. We're going to do this diagonally. So I can see here that point A, if I move diagonally, is going to go half. So I'm going to go half the distance in the opposite direction. And this is the location of A prime. And now point B, we're going to move diagonally there. 1, 2, 3, 4, 5, 6. So I have to go 6 in the other direction. 1, 2, 3, 4, 5, 6. And so this is the location of B prime. And then C. So we're going to move 1, 2, 3, 4. So now we got to go 4 in the other direction. 1, 2, 3, 4. And this is going to be the location of C prime. And once again, we just connect them together. So this is the reflection of triangle ABC over the line y equals negative x. Now let's take a look at the ordered pairs and see how they changed. So we see that A was at negative 3, 4, and A prime is now at negative 4, 3. And B was at 6, 6, and now B prime is at negative 6, negative 6. And C was at 7, 1, and now C prime was at negative 1, negative 7. So we can see here that the xy's did switch. We had a negative 3, 4, and now a negative 4, 3. So they did switch. So you can't really tell with the 6 and the 6, but here the 7 and the 1, and the negative 1, negative 7. But not only did they switch, but now both values changed their sign. So negative 3, 4, they switched, but the positive 4 became a negative 4, and the negative 3 became a positive 3. The 6, 6, they switched, but they each became negative. And the 7, 1 switched, but the positive 1 became a negative 1, and the positive 7 became a negative 7. So the pattern here, when we reflect across the line y equals negative x, is x, y becomes the opposite of y, negative y, the opposite of x, negative x. And that's going to happen every time we reflect an image across the line y equals negative x. All right, now let's talk about specifying lines of reflection. So we see here we have triangle ABC, and it's been reflected across some line to give us triangle A prime, B prime, C prime. And what we need to do is specify what and where is the line of reflection. So in order to do that, we need to remember the concept that the line of reflection is a perpendicular bisector for the line segments that connect a point to its partner. So what does that mean? So let's just go ahead and make these line segments. So I'm going to draw a line segment from A to A prime, and another one from B to B prime, and another one from C to C prime. And so the line of reflection is a perpendicular bisector for these three line segments, meaning that they're perpendicular, they make right angles, and that the line of reflection cuts these three line segments perfectly in half. So then how do we specify a line of reflection? Well, the first step is to do what I've already done here, which is to draw line segments from each point to its partner point. Now we need to find the midpoint of each of these line segments in order to find the middle. So we need to use the midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So here is point A is at negative 3, 3, and A prime is at negative 5, negative 1. So I have here, basically you're adding the two x's together and dividing by 2. So we have negative 3 plus negative 5 divided by 2, comma, 3 plus negative 1 divided by 2. Negative 3 plus negative 5 is negative 8, and negative 8 divided by 2 is negative 4. And 3 plus negative 1 is 2, and 2 divided by 2 is 1. So the midpoint of this line segment A prime is at negative 4, 1, which is right here. Now, I could have done this another way. I could have counted steps on the grid. To get from A prime to A, I would have to move up 4 and to the right 2. So what's half of up 4, right 2? Up 2, right 1, and that puts me in the same spot. Now let's do B prime. So we have 2 plus negative 2 over 2, comma, 3 plus negative 5 over 2. And 2 plus negative 2 is 0, and 0 divided by anything is 0. So 0, comma, 3 plus negative 5 is negative 2, and negative 2 divided by 2 is negative 1. So our midpoint of B prime is at 0, comma, negative 1, which is right here. And again, had I counted to get from B prime to B, I would go up 1, 2, 3, 4, 5, 6, 7, 8 steps, and to the right, 1, 2, 3, 4. So half of up 8, right 4 would be up 4, right 2, and that again puts me in that same spot. So now for the midpoint of C prime, so we have 5 plus 3 divided by 2, comma, negative 1 plus negative 5 divided by 2. 5 plus 3 is 8, divided by 2 is 4. And negative 1 plus negative 5 is negative 6, divided by 2 is negative 3. So our midpoint of C prime is at 4, comma, negative 3, which is right here. And once again, to get from C prime to C is up 4, right 2, and half of that is up 2, right 1. And so here is our line of reflection. And all we need to do now is figure out what the equation is that represents this line of reflection. Now you should remember, in order to write an equation of a line, you need to know two things, the slope and the y-intercept. So my slope here, I see that this line, like to go from here to here, is going down 1, right 2. So my slope is negative 1 over 2. And my y-intercept, B, is here at 0, comma, negative 1. Or just the y value, which is negative 1. And I could put that into my equation in slope-intercept form, which would be y equals negative half x minus 1. And that is the equation for the line of reflection in this example. In some other problems, it may be a little more difficult to identify the slope and y-intercept of the line, so you may need to use slope formula and one of the other forms, like point slope form, to get your equation. And if you don't know how to do that, then I suggest looking that up in another video. So let's take a look at this second example and go ahead and specify the line of reflection in this situation. So remember, step 1 will be to draw line segments from each point to their partner point. So here's my line segment from A to A prime, and from B to B prime, and finally from C to C prime. Next, we need to find the midpoints of each line segment, and I'm going to do this both ways. So first, using midpoint formula, add both x's together and divide by 2. So 4 plus 6 divided by 2, and both y's together and divide by 2. So 7 plus 3 divided by 2. 4 plus 6 is 10, divided by 2 is 5. And 7 plus 3 is 10, divided by 2 is 5. So the midpoint of the line segment AA prime is at 5, 5, which is going to be right here. And again, by counting, to get from A to A prime, I have to go down 4 steps and right 2 steps. So half of down 4, right 2 is down 2, right 1. That puts me right here. Now B prime. So I have here my x's, negative 1 plus 3 divided by 2, and my y's, 7 plus negative 1 divided by 2. Negative 1 plus 3 is 2, and 2 divided by 2 is 1. And 7 plus negative 1 is 6, and 6 divided by 2 is 3. So the midpoint of B prime is at 1, 3. That's going to be right here. Again, to get from B prime all the way to B, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1, 2, 3, 4. And half of down 8, right 4 is down 4, right 2. And that puts me right here. Now, C to C prime, we have 2 plus 4 divided by 2. And we have 6 plus 2 divided by 2. 2 plus 4 is 6. Divided by 2 is 3. And 6 plus 2 is 8. Divided by 2 is 4. So the midpoint of line segment CC prime is at 3, 4, and that's going to be right here. And once again, by counting, to get from C to C prime is down 4, right 2, and half of that is down 2, right 1, which puts us right here. Now let's go ahead and line up the points and draw our line of reflection, which is right here. And we can see here our slope to get from this point to this point is up 1 and right 2. So our slope is positive 1/2. And our y-intercept is right here in between 2 and 3. So that's going to be 2.5. So our equation for this line of reflection is y equals half x plus 2.5. All right, let's take a look at how we can apply this to a real-world situation. It says here, the figure shows one hole of a miniature golf course. It is not possible to hit the ball in a straight line from the T to the hole H. At what point should a player aim in order to make a hole-in-one? So my ball is here at T and the hole is here at H, and I want to make a hole-in-one. And I can't just hit it in a straight line because it's going to bounce off of that corner there, as you can see. So in order to make a hole-in-one, I would have to figure out where would I need to hit the ball on the edge of the course so that it bounces off and goes into the hole. Now, in order to make that happen, I need to understand that whenever I hit this ball towards the edge of the course, it's going to bounce off of the wall at the same angle that it came in at. And so I need to use that concept in order to figure out where to hit the ball. So I could use the concept of reflection to figure out what that point is. Again, I cannot hit the ball in a straight line from T to H, but if I were to reflect point H across the boundary, the edge of the course, then I would be able to hit the ball in a straight line there. So I'm going to think about reflecting point H across the edge of the course, which is this line segment CB, and that would put our new point right here, H prime, because H is 1 unit to the left of CB, and H prime would then be 1 unit to the right of CB. And as you notice, I could connect a straight line from T to H prime. Now, while that's not going to get me into the hole, this point right here, where my line segment intersects line segment CB, that is the point at which I need to aim my ball to get it to bounce into the hole. And so that point would be at 6, 3.5. So that would be where the player should aim the ball in order to make a hole-in-one. All right, so let's go ahead and take a look at one more example here. It says Kara is playing pool. She wants to use the cue ball, C, to hit the ball at point A without hitting the ball at point B. To do so, she has to bounce the cue ball off the side rail and into the ball at point A. Find the coordinates of the exact point along the side rail that Kara should aim for. So remember, the ball is going to bounce off the side rail at the same angle that it came in. So in order to figure out the right point that we need to bounce off in order to hit A, we need to take A and reflect it across the side rail. So if I look at A is 1, 2, 3, 4 units to the right of the side rail. So we need to put A prime 1, 2, 3, 4 units to the left of the side rail. Now what I'm going to do is I'm going to draw a line segment from C to point A prime. And there we go. And so now the point at which this line segment intersects our side rail, that is where we need to aim the cue ball in order to have it bounce off the side rail and strike the ball at point A. So that point here is at -1, -1. All right, I hope this lesson helped you to understand reflecting figures on a coordinate plane.